Welcome everyone to our new unit. It's called Stoichiometry. Stoichiometry. I'm not very good at phonetics. Stoichiometry. It's the math of chemistry. It's how things go together. So we've already talked about balancing chemical reactions, that kind of stuff. What information is provided by coefficients in a balanced chemical reaction? What does it tell you? Those balanced chemical reactions, those coefficients tell you the quantity, the amount. They tell you the mole ratio of how they react with each other. And they tell you the number of molecules or atoms of elements present and the number of moles. So it's kind of like, if you're making a cake or you're making some kind of recipe, you don't just put a cup of everything in. You have to put specific ratios. That's the only way it's going to work. So we are going to be using our mole diagram, but expand it, because up until now, the mole diagram was only used for converting within one substance. So for example, if I had 3.5 grams of sodium chloride, how many particles of sodium chloride could I have? Or if I had 4.82 times 10 to the 27th molecules of water, how many grams of water? So that's all within one substance. Now we can go between one substance and another substance using our expanded mole map. What is the expanded mole map? We'll be right there, and I'll tell you in a second. But again, we need a balanced chemical reaction. And we need a specific known measured quantity. So I need to give you that beginning piece. Like I have 25.23 grams of calcium carbonate, that kind of stuff. So here we have a balanced chemical reaction. I know it's balanced because I can count my atoms. I've got 2 sodiums here, 2 here, 2 chlorines here, and 2 chlorines here. And I'd have to be given a specific amount. So 3.5 grams of sodium. That's how we could go. And then I could figure out, if I have 3.5 grams of sodium, how many moles of sodium chloride do I have? Notice I'm starting with one substance and ending with another. So I'm going to need our mole map 2.0. All right, so this is in your notes a few pages back. I highly recommend going to it now. We're going to fill it in. So you'll notice on the left, you have substance A, our beginning. We have our known measured quantity. And we want to convert to the substance B, whichever we want to calculate to. So this should kind of look like a mole map mirror image. So here in the center, I'm going to put mole. And I'm going to put mass here. And I'm going to put, I can't remember how I had it in my notes before. I'm going to put volume here. I'm going to have particles here. And this is a mirror image, so I'm going to write volume here, moles here, mass here, particles here. Okay. Now, back to the left. Anytime you convert away from moles, you multiply, multiplication. And anytime you go back to moles, we'll divide. So put those operations in. Same over here. Anytime you leave moles, you multiply. Anytime you come back to moles, we'll divide. Okay. Whoops. Sorry. All right. Whoops. Technology. Okay, now let's talk about what we're multiplying or dividing by. Between moles and volume, this is 22.4 liters, remember? 22.4 liters of gas at STP. That's a lot of writing. You can just say 22.4. You know you need to have all those different properties. Between mass and mole, it's GFM, the gram formula mass. And between moles and particles, it's Avogadro's number, 6.02 times 10 to the 23rd. Okay, great. But now we need to bridge from substance A to substance B. And so what we're going to do is we're going to be multiplying by a conversion factor. CF is a conversion factor. Okay, we have talked about conversion factors before. Sorry about that. Conversion factors were used in dimensional analysis. All that is something like 2.54 centimeters equals 1 inch. That's a conversion factor. Or 1,000 milliliters are in 1 liter. Those are conversion factors. But when we're in stoichiometry, our conversion factor is going to be the mole ratios, the coefficient of your new substance over the coefficient of your original substance. So to convert from moles of your original to moles of your new, you need a ratio of the substances. So you take your balanced chemical reaction and you put the coefficient of what you seek, the new thing, on the top, over the coefficient of what you know, which is in the bottom, which we've always done. If I had, for example, let's say I have 36.2 inches and I need to go to centimeters, I would have 36.2 inches, and then I'd have inches on the bottom to go away, centimeters on top. I'd put my conversion factor in. So see how I wanted centimeters, so it went on top. It's what I seek. And what I already knew was inches, so that's why it went on the bottom, and that's how I was able to cancel it out. So that's how our conversion factor is going to be set up. Now, what are these conversion factors? They're going to be using the coefficients from the balanced chemical reaction. So that's why it's super important to have a correctly balanced chemical reaction before you go any further. All right, so use your mole map, expanded mole map, to help you here. We're also going to build on writing chemical reactions and all that other stuff. So everything's been building. We started with moles, and then we had chemical reactions. Now we have stoichiometry. Okay, word reaction. Hydrogen gas reacts with gaseous oxygen to produce water and energy. Part A, write the balanced chemical reaction. Hydrogen gas. Hydrogen is a diatomic element when by itself, which it is, phase, reacts with gaseous oxygen. Oxygen is another diatomic when it's by itself, to produce water, which is probably liquid, and energy, which you don't actually have to include, but it's nice that we did. Calculate the number of moles of water produced if 10 moles of oxygen are produced. Okay, so before I go any further, do I have a balanced chemical reaction? I didn't check that before I moved on. I have 2 hydrogens here, 2 on the right, 2 here. No, I don't. So remember, to balance, you put a coefficient here. Now I have 4 hydrogens on the left, which means I need, on the right, which means I need 4 hydrogens on the left. And we look good now. Okay, great. Now that I have my balanced chemical reaction, I have a given quantity here. Now I can use stoichiometry to figure it out because I have my proper ratios now. So if I look back to my mole map, to go from moles of one thing to moles of another, all I need to do is multiply by a conversion factor. That's it. So, calculate the number of moles of water produced if 10 moles of oxygen are produced. Okay, so I write down my given. Okay, so what I'm going to do is I'm going to go up here and I'm going to say this is what I seek. I'm sorry, this is what I know. Whoops. I know that. I seek moles of water. This is what I seek. So, conversion factor, coefficient of what I seek. So this is what I seek. Coefficient is 2. What I know is oxygen. The coefficient of that is 1. It's not written. Gee, that math is not very challenging. 10 times 2 divided by 1. So that is 20, maintain sig figs, moles. But now we're not going to say moles of oxygen. We're going to say moles of water. That was pretty easy. Okay, our next example. Nitrogen gas is forced to react with hydrogen gas and form ammonia, and you're given some energy off. Okay, so balanced chemical reaction. Nitrogen gas, diatomic by itself, plus hydrogen gas, diatomic by itself, forms ammonia. This is probably gas. And there's my energy. Okay, let's get balanced. Okay, so nitrogens are not good, hydrogens are not good. But if you look at hydrogens, we've got a 2 and a 3, which means we got to get to that common multiple of 6. So I'm going to put that here, and I'm going to put that here. Oh, and we're good. Okay. How many liters of hydrogen gas are needed to produce, 125 liters of ammonia? So ammonia is our given. It's what we know. So up here, I'm going to put K for no. And I seek hydrogen gas. So there's that. Now, if we go back to our mole map, to go from volume of one thing to volume of another, all we need to do is multiply by a conversion factor. Oh, okay. Whoops. So I start with my 125. liters of ammonia. I seek hydrogen, so its coefficient is 3. I know ammonia, so its coefficient is 2. So I'm going to take my calculator and I'm going to say 125 times 3, which is 375, divided by 2 is 187.5. Now, if we were going to be tricky, if we were going to do proper sig figs, it would be 3, so I'd say 188. Depends on whether your teacher makes you do that or not. And my units are going to be liters of hydrogen. Okay, pretty easy. It's just conversion factor. They're not all this easy. Number 3, gaseous carbon monoxide and gaseous oxygen react to form gaseous carbon dioxide while releasing heat. So carbon monoxide is the Greek naming system, CO, and it's gaseous. And oxygen, diatomic by itself, to produce CO2, and let's just say heat. Okay, so now I need to make it balance. I've got 3 oxygens on the left, 2 on the right. I've got to, let's see, what if I put a 2 here? Yeah, 2 here. That would give me 4 oxygens on the left, so I need 4 oxygens on the right. There we go. Good, good, good. Okay, calculate the number of oxygen molecules needed to produce 2.54 times 10 to the 26 molecules of carbon dioxide. Okay, so I am looking for oxygen, so that is what I seek. And I know carbon dioxide. I know it because I was given a specific quantity. So this is my know. So if you go back to your mole map, you see that particles to particles, again, you're just going to multiply by conversion factor. So I start with 2.54 times 10 to the 26 molecules of CO2. And I'm going to multiply it by what I seek. The coefficient of oxygen is a 1, not written. And it's over the 2, which is what I know. So I'm just going to do 2.54 divided by 2. And I get 1.27 times 10 to the 26. That hasn't changed. Molecules of O2. That's easy. Okay, now the last one is a little bit more challenging because, let's take a look. How do you go from mass to mass? Mass to mass, there are a couple different steps. I start here and I need to get here. Notice it's not a direct route. I have to first go to moles and then I can keep going. Because remember, the GFM is different depending on whatever substance you're dealing with. So that is going to be a little bit more work here. But before we do, solid glucose is burned, it releases all that heat. So remember, glucose C6H12O6, it's solid. Burning it, oxygen, combustion reaction. Yeah. Okay. So let's see, not balanced. So I need 6 carbons, 12 hydrogens, and 8 oxygens. Okay, well, how about I just start playing around? So let's see. That is good for carbon. That is good for hydrogen. So now I have 12 and 6, which is 18. Can I add? Yeah, so I have 18 here minus, okay, so I just have to do this. Okay, so that's a 6. Good. All right. What mass of glucose is needed to produce 845 grams of water? So 845 grams of water is our known. And what I seek is glucose. So again, I'm going to start with 845 grams of water. And remember, this is not just multiplying by the conversion factor. Now I need to go to moles first. So how do I go from grams to moles? If you didn't remember, go to your mole map. I'm going to divide by GFM. And let's round at the very end. So 845 divided by 18 is 46.9 whatever. And this is going to be moles of water. Okay? Now that I'm at moles, Now I went from here to here. Now I need to go from here to here. So now I can multiply by conversion factor. Now I need that seek over know. So I seek glucose, coefficient of that is 1. I know water, coefficient of that is 6. So I'm going to divide this by 6. 7.824 whatever moles of, now we're at glucose. Okay. So now I need to multiply by the GFM of glucose. So let's quickly do that. That's not when I had water memorized. I don't have this memorized. So this is 12 times 6. So 72. That's wrong. 12 times 1 is 12. And 16 times 6 is 96. So 72 plus 12 plus 96 is 180 grams per mole. So let me just plug this in here. Times 180 is 1408.3 repeating. Let's talk, and this would be grams of glucose. I don't know why I keep making that 6 so big. That should be a subscript. Sorry. If we were going to talk sig figs, take a look. It's 3. So it would technically be 1410 grams if you're going to do sig figs. I don't know if your teacher's going to make you. All right. I think I want to stop there. So if you have questions, let me know. Thanks.